We are now moving on to the second part of the workshop, which is about furnitures, predominantly interior furnitures. We already had a session uh, last time about outdoor urban furnitures. So if you want to catch up with that, it's already on the YouTube. So go ahead. And this is what our intention from interior furniture is. Interior furniture design and interior furnishing is like so particular to the context that doing a particular form or a particular design will not be highly relevant because it's your personal expression and you're allowed to do whatever you want. So with this workshop, we are trying to, let's say, exploit another superpower from BeeGraphy, which usually is not out there in any other tool, which is the configurator part. What How does it help us is that rather than creating one chair, parametrically designed chair, or any piece of furniture, we can create an entire family of these pieces, an entire range, so that I just define a system. I just write a methodology. And then whatever the kind of comfort I'm looking for, whatever is the ergonomics of the people is, whatever is the context around it, I can get a chair suiting that requirement immediately. So it could be like a low backrest lounge chair or a normal work thing, or it could be like a dining chair, whatever you want. You just define one process once, and then it's at a click of a button, you can get another design out of it. And how and when we can get another design, let me just give you a sneak peek what we will be able to achieve by the end of these 45 minutes. So this is, let's say, my configurator mode. I am pretty sure that you are aware of it, but if not, we will, no problem. We will go in detail in the next hour about this. So what this mode empowers us to do is that we are, as designers, are not required to share the script or the process to anyone. The first thing, that being a completely online tool, there is no requirement for anybody. Let's say if somebody is your client and you want him to give him the freedom that, okay, just change the chair the way you like it. They are not aware of how to use a software. They might not be having them. So you can just share this configurator link to them. And then all the variables can be seen on the right part of this window. And then they can easily change the parameters which they like. So for example, they like a higher handrest instead of a lower one. Uh, Let me just reload this so we can get onto it. In the meantime, we can start setting up our script to achieve that result. Pretty easy in your graph. I am pretty sure all of you have a BeeGraphy account by now. So in the editor mode, simply click on a new model, and let's say we say family of chairs. Great. We open this window. It is still loading. Yeah, here we go. We have our chair. Let's say I want a smaller handrest, and then we immediately get to see the design on the left. We have so many different parameters about aesthetics, how much meshing you want to have here, what should be the thickness of the frame you want, a sleek design or a bit bulky one, and most importantly, the ergonomics, what is the front width we want, how high we want it to be. So with this thing, we get the power that I need not to compromise with a standardized product from the market. And as a designer, that is one of our biggest intention, is to provide as much comfort to the user as possible. So based on the individual design preference, based on the individual body preferences, they can be able to configure their chair and immediately see how it looks like. So now let's get into it to start. So we want it could be, if I wanted a static chair, it could be done in a much simpler way. But with this, we are trying to parametricize everything as much as possible. So there is no static inputs. Everything comes from the user or are connected to the other parts of the design. So apparent, to, looking from an outside, it might look like the script is quite long, but but the intention is that by having a slightly long script, we get the freedom to have any design, any configuration out of it in the future, based on our personal needs. Perfect. So let's start by taking the basic inputs about these things, about what is the height, width, and depth of the chair. We could have done it that the front and the back width and the height is the same, but then we could not have achieved this kind of a slope, which a lot of people prefer for their comfort. If I see this chair, uh, what are the things which comes to the mind? First thing is that it is always symmetrical, and predominantly all the chairs are symmetrical. So what we can do, we can design just a half of it and then eventually mirror it. And then we can get the entire chair. It will just help us uh, to reduce some steps and reduce the computation time. The second thing is that there are two major parts. The first are the surface, two-dimensional objects, which are these meshes, the first one for the back and one for seating it. And the second, the unidimensional curve or these pipes which form the whole body of the chair. Let's start by making this piece, which predominantly imbibes, takes care of all the stuff related to the seating comfort of the people. So what is the height in the front and the back? What is the width of the chair? And also what is the depth? Let's start by creating multiple range inputs for all of them. I want first input from the user. What is the front width? And then we can define a range here, the minimum and the maximum. We do not want like a chair below 30 centimeters is definitely of no use. So let's make it 30 to 60. Anything wider than 60 centimeters which should ideally be termed as a couch. So yeah, and then we can have a step size of 2 so that we are not doing processing at every small step. So I got a node by which I can enter the front width of the chair, this width. Then I can do the same thing for the back side. And then the next thing I want is the width, the depth of the chair, how deep it is. By depth, I mean this dimension, whether it is a thin, slender, or a pretty thick one. So the depth of this chair is much lesser than the depth of this chair. So again, the kind of comfort you want to achieve. And in the depth, we can go a bit deeper as well. If somebody wants to like lie down, let's say 75, and we can start by, let's say 40 centimeter deep, the minimum. Great. And after the width and the depth, let's go to height. Front height. I can have a very low chair up to 30 centimeter and it could be as high as, let's say half a meter, 50 centimeter. Again, I can have the same range for the back thing as well. Okay, so now I have gotten like these 5 range inputs, which the user can provide. So I think I have all the inputs required to create this piece, the one side where people actually sits. And how we can create this piece, let's just do a little sketch.
Ayush, I think you made the depth too big. I mean, the max.
Oh, yeah. It should be 75. So yeah, so let's say this is the kind of side panel we want to achieve. So what we can do, we can create these 4 points based on the width and the depth and height provided by the input, and then we can connect them by a polyline, and as and then in the end we can provide a fillet if we want to have a curvilinear field to it. So let's start creating by these 4 points. The bottom left thing. First thing that what, as I told you before, that we want to make only half of the chair because we'll mirror the other half. So whatever the user defined input is for the width of the chair, we can just cut it by half, divide by 2, so that we are just making the let's say the right part of the chair. So I can just take a division and then I can divide by 2. I always want it to be divided by 2, so I can just simply enter it inside inside the panel itself rather than having any kind of user-defined input. Great, we get the half of the front width. Similarly, we can get the half of the back width. My grid is not visible. Let me just switch it on. Perfect. So let's create the bottom point here. Let's try to create this point here. So what this point should have, it should just have the front width. And for this point, it should have the back width as well as the depth of the chair. Let me start by constructing a point. It's a 0, 0 point at the moment, but where we want it to be at as the front width point, where it moves the x domain, x side. So this is perfect. This is the front bottom point. I can have the same point at the back at the x, but it needs to move into this direction as well. So for that, we have to put the depth in the y side of the chair. Great. So we got the depth of the chair and the width of the chair on the bottom side. Now we want to have the top points as well, where people are actually sitting, the sitting height. So what we have to do, we just have to take these 2 points and move in the z direction. So I can copy the same point and then just apply the front height as the z point here. Perfect. It is pretty high. Let's get it a bit down. And for the back side of it, we can just take the point we defined here, the back point, and move it up in the z direction. Great. We get the point. Let's say if the back height reduces, this point should ideally go down. It is happening, so we are okay. It is happening as expected. The second thing which we can see here, that we are not defining like perfect rectangles here on the side. It is not, if I just give the front view of it, that it is not a rectangle, but rather we have a slightly smaller base, and then we get the panel which looks something like this. So the top 2 points are okay, but what we see, the bottom 2 points are right now at this location, the front and the back. We have to move them inwards if I want to get that effect that the base is smaller than where the people are sitting. So if we want this to be smaller than this part, we just have to shrink them in. Multiple ways to do it. Probably how we can do it is by, let's say, creating the line between them and then scaling that line to from its center point, scaling it down from its center point. So let's first create a line. No, this is the top line. We want to scale our base. So we have to use these points, the front and the back. Perfect. And now I want to scale it at the midpoint of this line. So first scaling goes to geometry and hit the midpoint. We already have a component known as middle point. Let's get the curve through here, and let's get the point as the center point. Now, if I just turn out the visualization of this line, we see that the line is getting bigger because we have a scale factor of 2. It's up to you whether you want the user to have control of this factor or it is a static part in your design. For me personally, I would like the users can take care of how much scale they want the bottom place to be. So I can add another range input, and I do not want definitely it definitely to be bigger than the top part. So my maximum range definitely is 1. And I also do not want it to be smaller than half of this because then the chair will become unstable. So let's put 0.5 as the minimum limit for it. And then if I put it in the factor, and then we see that I have a smaller base now. I do not want to see this middle point. And what we saw some time back that we need these 4 points, and then we are going to create a polyline and then fill it. And to get the points of this line, we can just directly use the endpoint component, and we will get these 2 points. So let me switch off the visualization here, and the visualization of the line, and now we have the 4 points. Simply, we can merge them into to create a polyline. Merge will just combine all of these individual points together into one list. So if you go to the list, visually you will see only one point to provide all your input, but there is the hidden feature. Whenever you click on any of the input node, just click on add port, and you can add as many input ports as you like. Perfect. Second point goes in, the third point, and the fourth point. Let's switch off everything. I have all the points here, and now we just need to create a polyline out of it. Polyline, we see that the order is very important when we are creating a polyline. My fourth point and the third point should ideally be reversed. So we can just do, I can select the fourth port and click move above, or I can change the input order of these things. No, I did something wrong here. These 2 points should be changed. Okay, so we got the correct order now, and I want the polyline to be closed. So I can just simply click on the Boolean and we get the closed line out of it. Great. We have the main panel where people are sitting, which is parametrically controlled. Let's say if I want the front part to be higher, this point should go up. Let's say whether it happens or not. Front height. Yes, working as expected. If I decrease the back width, this should come inside. Back width. Yeah, okay. Everything is moving and working as we intended it to be. So we got the first part for our chair frame, which was, let's say, the most important and the most tricky part. And let's apply this fillet as well to get this curvilinear feature there. Let's do fillet geometry. The curve goes in there, and I want the fillet radius to be controllable by the user as well. Range input goes here, and then it is fillet radius. What is the minimum? We can have like, okay, at least you can have minimum as 1, and maximum it can go up to 12 centimeter, 10 centimeter, the way you like it. And then let's have a step of 1 centimeter so people can change it accordingly. I hide the chair part, and then as I am increasing the fillet, the curve is getting more prominent. Great. Let's keep it like this. So we got the first part. Now let's go on to the second part, which is let's do this back rest thing. And as we see here, that this backrest is actually an extension of the back curve of the panel that we already created. So the back rest is extension of this curve. So we can start by using this line here. Okay, for this line, we need this point and this point. So these two line points are responsible for this line, not exactly this point because we already scaled it. So we have like a let's say a different, a smaller, a scaled down, a moved in version of it. Let's start by creating this back panel line. And it should be this point, which is the scaled down version, and this point. And you do not see it at the moment, but I promise you there is a line. You can see it slightly in yellow. So this is the line which we just created here. Now to extend this line, what we can do in the same direction, and mind that it is not like a 2D line because we are changing all the parameters around the chair. So we can create a vector, and there is a wonderful component to do that, which is vector by 2 point. So what we have to do for this component is that I have to provide the first point and the second point, and then this component gives us what is the direction between them. So it's not necessarily be along a cardinal direction, X, Y, or Z, but a combination of them in any possibility. So we can get the points directly from above, but to keep the script a bit cleaner, I will just do the endpoints to get the endpoints of this line. And then I start my vector from this point and end it on this point. So this blue line you see, this is the direction which this is taking. Okay, I now got the direction where I want my backrest to be, but I want to get a user input how high they want their backrest to be. So again, a range input. And let's have a minimum of 60 centimeter to 120 centimeter, and then we can have the intermediate points at every 5 centimeter for user to input their backrest height. Okay, and to get the top point of the backrest, what I can do, I can simply move this bottom point up to a height of this dimension in this direction of the vector. So we have all the input required. So let's just do that. I want to move this point in this direction. So to combine this vector with this numerical input, we can use the component which is known as amplitude. So I get the direction as the vector, which I found by using a 2 point vector. And then amplitude, or the numerical side of this vector, goes here from the range input, which is user defined. And I can plug in this combined thing inside this. Great. I got the height of the backrest. This is the point where the backrest should stop. If it is going up and down, as I do, yes. So everything seems to be working okay. Now, what I want to do is to have this connection till the center point to this point, from here till here. Right now, what we got is this particular point, the extreme height of the backrest. So let's just create a line from here to here. And how we can do that? We know that this plane is already existing and we want to mirror our chair along this y-axis. So I can just project this point onto this YZ plane. And then we just get that third point as well. And to project that thing, we can use is a closest point to either geometry or plane. We have a clear plane along which we want to mirror this half of the chair. So we can use that plane directly, which is the YZ plane. So let me take a YZ plane and give me the closest point projection on that thing and this point. Great. So I got this point from the from this component, which is closest point. I already have this point, and now I just want to connect it to the chair base frame which you already created. The thing is, if I connect it to the bottommost point, there will be like a straight line going till the very bottom. But we want to have this curvilinear uh, thing, which is like a kind of floating impression it gives. So what we can do, we can create this frame just till the midpoint of this line. We already have this line here, here. So what we can do is just let's take a middle point of this line. Yeah. So now we got these 3 points, first, second, third. Let's just connect them in a polyline and we will have our the second element of the backrest as well. We use the same thing as before, which is list merge. Let's start with this point, which we found from the closest plane. Let's set the port. Let's use this point. And then finally, the bottom. Perfect. We got all the 3 points in one list. Let's create a polyline around it. Great. And now for this particular polyline, we do not want it to be closed. We want it to be like just a backrest here. If we click on this Boolean, it will be a triangle like this. We do not want this line. So let's just not do this. And then finally, let's fillet it as well. Geometry. And for radius, we can use the same radius which we used from the user in our last step. Let's hide everything else. And now we have our second, let's say, unidimensional element as well, working fine. Third thing, let's create this handle here. Simply, what we can do, we can follow the same approach, what we followed for the backrest, that we took this line and we create a vector out of it as an extension of it. Similarly, we can apply a thing here. We can take this line, we can create a vector out of it, and then we can, let's say, kind of extend this thing. And then we can combine all of them into a polyline and we can fillet it, and then we will be done. So I need this line here. I already have this line, which we created here. So let me just take a relay. So I can take this line elsewhere. Let's take it up. And now I want to use this line. For this, again, we need only 2 points. First point will be coming from the end point of our line. And the second one is this point exactly. Okay, I have this line. What we can do to create a vector for this line, we already have the vector from 2 point. So create this line, we can simply find the endpoints first, and then we can do vector from 2 points. First, second, we got the vector. Now to create an extension, we can take a user input, how high they want the handle to be. Let's have 10 centimeter to be minimum, maximum it could be up to 20. And then they can get any step between at like in a sequence of 2 centimeters. Okay, we have the range input, and I now need to move the point. Which point I want to move? The top point by this dimension in this vector. We have all the input. I want the top point to move in a vector amplitude in this particular direction and in a height of this. And then let's combine all of them. Perfect. We have this point moving as per the vector input. So I have this point. Now let's take a similar handrest point for the back part. We can copy the entire thing. And then let's just add this curve here. But one thing is that we do not want the user to enter a separate value for what the height of the backrest in the handrest in the back is. So what we can do is we can just take one input and maybe just divide it, make it smaller slightly, and it's just connected to that one. We can divide it by 2 or 3. Let's check with 3 how it looks like. Okay, so this is the point after changing it. And then if I increase the height of the handrest, both of the points move simultaneously, works perfect. Let's just create a polyline now. And similar to the process we followed here, that we do not want we want to keep the curve at the bottom alive. So we will use this midpoint to start our polyline and not the extreme bottom point. To get the midpoint of the line, pretty easy. Curve middle point, we already have a curve. And we can do the same thing for our curve here as well. So now if I switch off everything, we have these 4 points. Let's just combine them together, the same methodology as before. Let's merge them and then polyline and fillet. We need not to repeat the steps over and over again. So I just copied this block from our previous part. And then let's just change the points there. Perfect. We do not want a line to be here. We can, if you like it to be. In my particular personal case, I do not want it, so I can just turn off the Boolean toggle and we are good to go. Okay, we got the handrest as well. We got the backrest. We got the main side panel. What we do not have is the plane where people are sitting. So we need to create this frame around. Similar step for creating this frame. What we can do, we can move this particular point. So we can have this line, and that can be like the starting point to create this part of this of the chair. Okay. So what we need is we need this particular point, which we want to again uh, uh, project it on our YZ plane, which is this point, one of these two. Yeah, this point. And then let's say closest point on plane, what plane we want to project it on, which is the YZ plane, which is this particular vertical thing. Let's take the plane in there and let's take our point. Great. So we got this point, we got this point. Now what we only need is a center point here so that we do not overshoot whenever there is a high fillet. To create this point, what we can do is we can create this line here, and then we can take the midpoint of this line. So I want to create line from these 2 points. Yeah. And then take a midpoint of it. Okay, great. So we just now need to create a similar polyline between these 3 points. First, second, and third. This is my first point. And then I can just put a relay here to get the second point, and this is the third point. We need not to manually do anything. We can copy the same block, and then we can provide the first point, the second point from the relay, and the third point. And then this we do not want, so we can remove it. And then switching off the points. Cool. We now have a frame, a boundary where we are seating as well. So we got 4 of these components. 1, 2, 3, 4. We are getting closer. One element which this chair has is this back support, which is like a counterbalance, because horizontally there are no connection here. So this helps in stabilizing the horizontal deflection. And what this element is doing is starting from the middle point of the bottom curve, which is okay. And then it is going vertically down from the midpoint here and then getting connected there. Okay, so let's get this particular point vertically down, which is this point in our script, the middle point. Remember that we will mirror everything along this axis. So yeah, this is the middle point from where we have to get the element down and then connecting it somewhere here. How we can get this point we already used, not this one, but this one. Okay, so we already have this point. Now let's just move it vertically down, which is move when we know that we have to go like in a perfect axis in a cardinal direction. So we can use a unit vector, which is z. We can go, so we do not have to create a 2-point vector based on existing line. This is the geometry which we want to go down to, and how down we want it to be. We can just like define define a number that just make it 20 centimeters or 30 centimeters higher from the ground. So let's say, and higher from the ground, what is the total height? This is the height. This is the height of the backrest which users already entered. So if I just go there, what is happening? This was the height of the user that they already entered. We want our point to be somewhere here. And let's say this is 20 centimeter. So to get this height, we can just subtract the 20 centimeter or 25 centimeter from the user given backrest height. So yeah, let's use the subtraction. there should be the backrest height, which is this. Let me rename it so that do not forget it. From the backrest height, please subtract 25 centimeter. So I'm creating a number constant. It is not a user defined input. So I'm using a not using a range input there. And then this is the number. Strange thing, I see that I wanted the point to come down, but it went up. So what we have to do, we have to just use a negative or an opposite component to change the direction of it. So I change the number to a negative number, and now we see that the point is coming down. I got this point, I got this point. Now where I have to merge? The center point of this bottom thing. We already got this point. Remember when we were scaling down in the very first step, we use the center point of this line. So we should have it somewhere. Then this is the point where we were scaling. So yeah, this should be the middle point along with we scaled it. Following our same routine, let's merge all of these points together. The first point is this one, which is this point, the one on the top. The second point is this one, which we got after moving it vertically down. And our final third point is the center point, which we just found out. Great. We can switch off the visualization and then see how it looks. Yes, it is looking as in the design. Let's do one thing. Let's mirror them and then see whether the whole chair is coming as expected or not. So let me take a merge component to have all our different parts into a single list. We have a total of 5 parts, so let me add more ports. And the final one. It is always preferable and suggested to flatten if there might be data coming in different streams and different branches. So just flatten it once to be safe. And then let's mirror it. And when we mirror it, yes, we get the chair skeleton perfectly all right as we wanted it to be. So, okay, great. This part is working. I can disable all of them or I can keep them. It's okay. So we have the chair skeleton done. We just have to do a piping on it, which is an easy part. And then now let's get the two-dimensional elements, which is this surface where people are sitting and the back surface. What is this seating surface doing? The seating surface is it is not covering the entire thing. We have a slight gap on both front and the back part. So only the linear element, no curved part, but only the linear element from this thing or from this chair boundary is being used. So what we can do is we can use this polyline curve and then we can extract only this particular length from it. Let me show you how it can be done. So this one was this element, perfect. Let's explode it. So what explosion does, it gives us individual curves and points rather than a complete thing together. And we want one particular curve, which is this one. So we can use a list operation, which is known as list item, which gives one item from the list. So from all the curves out there, I can hide this. I need only one item. And you see, when you just select the component, one of the curve will be highlighted in yellow. I am not sure whether you can see it clearly uh, on the stream or not, but at the moment, the bottom curve is highlighted in yellow. So let me just change the index number, and then it is 4 now, and then find the correct curve. Other possibility to do it is by using a simple range, and then or hiding the other parts would be helpful as well. Yeah, this is just to show you what is happening when I'm changing the number. If I do 2, no. Yes, perfect. This is the line we wanted. And then to create a surface, what we can do, we can again mirror it along this YZ axis, and then we can loft these two curves together into a surface. Mirror, and then we got the two line. Why we are not simply extruding it? Because it is not a two-dimensional planar. It is not a two-dimensional planar surface parallel to the cardinal dimensions. There are changes in the back height and the front height, back width, and the front width, so it is more like a trapezium. And it is not parallel to the XY uh, plane. It could be moving up and down. So by following this method, we are robust, and doesn't matter what the user input, we will always be able to get the correct surface out. So let's just add these two lines there. The first line is this one, and the second line is this one. And we got the surface out. So the surface is perfectly fine. We are now just want this pattern onto it. And if we were using, if we were on Grasshopper at this moment, we will be required to use a plugin like a Lunchbox to do this. But fortunately, uh, in BeeGraphy, we already have that capability built in. And then if you go in your tool set, and if you move around somewhere, you will find hexagonal mesh, which is exactly here, hexagonal paneling. So we need to do a paneling on this particular surface in a hexagonal way. Great. Now what we can do, we have these hexagonal panels. We can just offset them inside and then create surface between them. But I want this panelization is too big for me. If a child is sitting there, it might fall down in between. So I want to parametrically control how big the meshing is. So let us take an input from our user, how big they want the mesh uh, opening to be. So let's take a range input. Let's say 1 centimeter will be too small. So let's say 2 centimeter to 3 centimeter, or up to 4 centimeter, and they have a step size of half a centimeter. What I will do, I will just measure the length of this side and divide by this. So we get the number of U or V, or the number of panels in this direction. Similarly, we can just do we find the length of this one, and then we divide by this, and then we have the other thing. So let's take the length of this side first. Curve length, we already have our curve. And then we can simply divide them. And then we can have But one thing which we have to take care here, the number coming out here is a natural number. If you just see here, it is 26.07. But when we are defining u and v, we have to provide an absolute number. So we have to just, let's say, do a round off so that everything is clean and the input for our paneling tool is well defined. Great. So this side is done. We never created this line. We just lofted this line with this line, so we cannot directly measure the length of this side. So what we can do, we can use this point, which where component by which we want to identify the proximity of the things. Yeah, so curve proximity. So what this component does is if there are multiple curves defined, it tells us what is the closest proximity between them. So this is our indirect way of identifying that dimension. So let us add both of these curves here. The first curve, the second curve, and what we get out as a number is the distance between them. Let me just reload it. If there are any errors, because it is a web-based thing, just reload it and 90% of your problems will be solved as we see. Okay. Again, I just need to divide and round off the number so I can copy the two nodes, divide the top number here. We are already rounding it off and then add it to the V side. Our mesh should be homogeneous now. Perfect. But it is extremely dense. So I'm going to increase the dimension for now. And then we can come back later and then make it thinner. Okay. So we got the mesh. And what we can do now is we got, like, let's say our individual cells like this. We can offset these cells inside. And then we can put a surface between them. So we get like a slightly smaller cavity. What we are going to do, we got the hexagonal panels main, and then we are going to offset the curves. We want to offset the hexagons. And how much? We enter it directly here. That's a 0.6. But what is happening? They are going in the other direction. They're overlapping with one another. I want to offset them inside. So I will just put a negative in front of it. And it looks good. Perfect. Now we can just loft our inner hexagon with our outer hexagon, and then we get a surface in between them. For loft, we need to provide two surfaces. Here we are working with a large data set, so we can just draft them so that all of the offsetting, all of the lofting can be done in a single step. Perfect. I want the first curve and the second curve. Lofting happened. Great, we got the mesh as well. If I just hide them, awesome. So we got the base surface in. If I switch on this mirrored geometry and this geometry, we have the front sitting base as well. We just need to create the back surface. The process is extremely similar. All of the meshing remains the same. We just now need, instead of a line here, we just change the input line from our back. So what we can do, we can take our back line, and then again, we can similarly, this is our back line. Great. We can similarly uh, explode the geometry and list item to get the correct curve, and then we can just input it there. We exploded the geometry. Now list item. Great. So this is our item. We just now need to apply it on this thing. Let me create a node here, and then we can copy the entire thing. So we are going to connect it here before the explode, and then we need the index to be 2 as we identified. Let's just connect the base curve, and our index is going to be 2. And as soon as we did that, we got our back meshing done as well. So we are almost there. We just need a frame around our unidimensional elements, which is, let's say, the easiest part of the entire evening. We can use a component which is pipe. And then we have to define a radius, which we want to take it from user. So it needs to be a range input. And it needs to be a radius. So let's say I can have a radius of minimum 1 centimeter up to, let's say, 2 or 3 centimeter. Let's go with 2. I want to start with a radius of 1.2 centimeter. I put the radius here. And then in piping, I need to put both the left side and the right half. So I can merge them together into a single list. And then we can just provide this curve as input to our chair. And we have all the piping being done as well. If we just turn off the visualization of the curves, we will not see the red lines. And then simply you can apply all the different kind of materials. We already saw in detail about material application with Divya. So I need not to go in detail for that. And then let's try to see whether it is working parametrically or not. First thing I want to change is I want to increase the backrest height. We have our backrest height somewhere. Let's increase it. Let's see what happens. It took a couple of seconds and perfect. I have a chair which has a much higher backrest. I want the chair to be deeper. What we can do is we can increase the depth of the chair from 60 to, let's say, 70 centimeters. It will take 4 or 5 minutes, but you see the power that we just created a system out, and doesn't matter which kind of chair we want, what kind of function we want, everything can be achieved directly. Cool. Any questions you guys have now about this before we move